Hi friends, today we are going to discuss about design of helical gear. The main contents which is coming are what is helical gear, the different terms involved in helical gear, design of helical gear, and also a problem and its explanation. First, what is meant by helical gear? In case of helical gear, we can see that the teeth of the gear are set at an angle. Means it is not parallel to the central axis. The teeth here is called an helix, and this allow the teeth to mesh gradually between two teeth. And when we are going to meshing between two teeth, we can see here that the small gear is the driver and the large one is the driven. Here you can also see that the two gears are set at an angle. Next, different terms coming in helical gear. First term is helix angle. It is denoted by alpha, and it is an angle made by the helix. Means in the figure you can see that the helix means the inclined surface, and central and at the central you can see the shaft. So the angle between the inclined surface and the central axis, denoted by the dotted line, is called helix angle. Then axial pitch, it is denoted by PC. It is the distance between an helix, means a helical tooth, and the central axis, means the parallel distance between the helical tooth and central axis. Next is the normal pitch. Normal pitch means it is the distance between two helix, means two helical teeth. Next we are going to design a helical gear. When we are designing a helical gear, the different terms we are dealing with are torque, tangential load WT, peripheral velocity V, then velocity factor CV, then phase width B, module using Lewis equation, and finally checking for wear. These are the different terms when we are dealing with design of helical gear. And here we are dealing with a problem. In this problem, we are finally finding out the pitch and end thrust of the gear. And in the question it is given that a helical cast steel with 30-degree helix angle has to transmit 35 kilowatt at 1500 rpm if the gear has 24 teeth. Determine the necessary module. Then pitch diameter of face and face width for 20-degree full depth teeth. The static stress for the cast steel may be taken as 56 megapascal. The width of the face may be taken as 3 times the normal pitch. And it is finally asking the question, what would be the end thrust acting on the gear? The tooth factor for 20-degree full depth involute gear may be taken as 0.154 minus 0.912 by TE, where TE represents the equivalent number of teeth. Means here the tooth factor is directly given in question. So next we are going to the explanation of gear. Means here the data book is this Mahadevan, means design data book by K. Mahadevan. Means if we are going to different terms, beta, here beta means in the data book it is given as helix angle, means helix angle is given as beta. Then power is given as 35 kilowatt. Then RPM is given as 1500 RPM. Then ZG means number of teeth on gear is 24, and stress is given as 56 Newton per mm square, and phase width B is equal to 3 times the normal pitch. And Y means tooth factor, means Lewis form factor, which is equal to 0.154 minus 0.912 by ZD. This is an empirical relation. Then next, power is equal to the standard equation 2 pi nt by 60. From the equation, torque is equal to power into 60 by 2 pi n. N is already given in question 1500 rpm. So from that we can find torque. Upon finding torque, the next step is find the velocity of the gear. Means velocity, the standard equation is peripheral velocity pi d n by 60, and diameter is given in question itself, means 24. So pi d n means pi d n by 60. If you are using standard equation, you can see that velocity is calculating as 5.652. Upon going to next page, next slide, from page number 211, if you are referring data book Mahadevan, page 11, page number 211, equation 12.22a means set d. Set d means equivalent number of teeth, which is equal to set, which means number of teeth by cos cube beta. Beta means angle of helix, which is given in question as 30. So from there we can find set d, and upon getting set d you can find y, and upon getting y, the next step is to find tangential force. Means the torque we already know, so ft is equal to 2mt by d. Sorry, ft is equal to 2mt by d is the equation. From there you can find out tangential force. But the one problem is that the d means pitch circle diameter. D is not given, but we know module is equal to diameter by number of teeth. From there you can find d, pitch circle diameter, equal to module into set, that is m into set. So in the place of d it is substituted as m into set. From there you will get an equation for ft in terms of module m. Next one, upon referring to page number 204 in Mahadevan, you can find the equation ft is equal to sigma d cv bym by cw. Means that is the Lewis equation. It is called the Lewis equation. It is given in page number 204. So ft we already know now. Sigma is given, cv is already given from the data book. So substituting all these, we can finally see that substituting all these we can finally solve the value for m. Means from this equation you will get all the terms in m, and finally you will get the term value of m as 11. And one more thing asked in question is FA, that is axial thrust, that is FT tan beta. FT we already found out. So upon substituting FT, we can find out FA as 917.99 Newton. So this is about the F problem which is discussing with design of helical gear. Thank you.